We're moving on from chapter 1 now, so we're going to be looking at the modulus function, which is the start of chapter 2. Now, by now you have sent me your sheet on modulus function graphs, which I asked you to do. That kind of gets you in the mood for this topic. So let's have a look at what we need to do. This is going to be in order to enable us to answer questions in 2A. So it's really important that we understand this. I'm not going to whiz through this. It's really, really important that we understand this as best as we can. So I asked you last week to draw some graphs such as things like that. So let's have a look at that. So I suggested that it was a good idea to start by drawing that graph. Once we've got that graph, then we can remember what the modulus function does, and we can transform or kind of alter this graph in order to turn it into a modulus graph. Right, what does this graph look like? Well, it's got an intercept of 1 and it's got a gradient of 3. So it's going to look a bit like, that. Okay, and then what's this point here? That would be minus a third. Right, and then we remember what the modulus function does. If you put a positive number into the modulus function, it just gives you back the same number. If you put a negative number into the modulus function, it gives you kind of the positive equivalent. It gives you almost the size of the number, but not what we call, not whether it's positive or negative. For example, the absolute value or the modulus of 3 would just be 3, but the modulus of minus 3 is also 3. It's almost like the length of the number. It doesn't matter which way you're going along the number line. It just needs the distance from 0. So there's loads of ways of considering it. What it's actually doing for the negative values is taking the negative value. It's doing minus 3, which then gives you a positive 3. So all of these values, instead of minus 2, this function is going to give me 2. And instead of minus 5, this value is going to give me minus 5, so it's going to give me positive 5. So this graph then ends up looking a little bit like this. And remember, it's never going to go below the x-axis if you've got everything in the modulus sign. So it's going to be exactly the same in that it's going to look like that. But then we said, instead of going down to minus 1, minus 2, we're going to have minus 1, 2. And instead of being minus 2, minus 5, we're going to have minus 2, 5. So it's kind of reflected up over the x-axis. So it's going to end up looking a little bit like that. Okay, our job in 2A is to now solve equations that involve modulus sign. So let's carry on with this example. So we would be asked to solve something like modulus of 3x plus 1 equals 7. We would be asked to solve something like that. It would be really easy, wouldn't it, if we were asked to solve 3x plus 1 equals 7, because we would say, well, when does this graph equal 7? And we would go across and we would find the corresponding x value. And that would correlate to us solving this equation, taking away the 1 and then dividing by 3. You'll notice that it becomes a little bit trickier if we've got a modulus, because now, look, the value of 7 now has 2 values associated with it. So we need to now do 2 things in order to get this answer. We're going to solve all of these questions with the help of a graph. So I'd like you to get into the habit of drawing a graph for every single question. You'll notice that if you do, you get it right every time, and if you don't, you probably don't get it right every time. But I don't want you to take the risk. I'd like you to draw a graph for every question. So I've drawn y equals 3x plus 1, modulus of. I'm going to draw the graph of y equals 7. Your graphs don't have to be accurate, but it's going to help if they're kind of accurate enough that you can see roughly where these graphs are going to cross. So you'll notice that one of these intersections arises from this part of the graph, which is the kind of the unaltered part of the graph. This part agrees with this graph of y equals 3x plus 1. So this part of the line is exactly 3x plus 1. Because there's no negatives, nothing's happened. So in order to get one of these solutions, this solution in fact, I'm going to solve 3x plus 1 equals 7. That's going to give me this solution because this part of the graph is just the line 3x plus 1 because I haven't got to any of the negative bit yet. So then I can solve it. So 3x equals 6, so x equals 2. So one of my solutions then is going to be x equals 2. We need to now think about how we're going to get this solution. So this solution comes from the part of the graph which was down here, which has been reflected up. Remember we said that that's the equivalent of putting a minus sign in front, because then you end up with a minus of a minus, which becomes positive. So this part is the part that's been changed. So it's this part I'm going to write as minus bracket 3x plus 1. Because all of this part was negative, I know that the modulus function has just given that part of the graph a minus sign. And we want that to equal 7. That's why the graph's really important, because you need to know which part hasn't been altered and which part has been altered. So we get that, so that's minus 3x minus 3 equals 7. So minus 3x equals 10. So x equals minus 10 over 3. And hopefully from the graph we can see, yeah, that looks about right, doesn't it? Minus, where's 7? There. 1, 2. I think I can hear people screaming. That should just be minus 1. Yeah, just minus 1 times 3x minus 1 times 1. So that's just minus 1. Sorry. So that's an 8. I thought it didn't look right from the picture. So minus 8 over 3. Sorry. Right. Minus 8 over 3, that looks about right, doesn't it? 2.7. Yeah, fine. So there are our two solutions. We got that by drawing the picture and by deciding which part of the graph, which solution was going to come from, I'm going to call it the unaltered part of the graph, and which part was going to come from the fact that this used to be negative and now is positive. So that's one thing that you can be asked to do. You can be asked to solve an equation like that. You could also be asked to solve something like modulus of 3x plus 1 is less than 7. And again, you're going to need to draw the picture and you are going to need to find these 2 points. And then you need to think, and every case is going to need you to think. There isn't just one rule that you can apply every time blindly. You're going to have to think about each case individually. So I want this 3x plus 1 function-y thing to be less than 7. Well, we know that they cross at 2 and minus 8 over 3. And we're interested in when this modulus graph is less than the 7. Well, look, that happens between these two values. That's when this graph is under this line. So that would be true for x being between minus 8 over 3 and 2. And notice that it's a less than and not a less than and equals to. The only difference, if it were a less than or equals to, I would just put the little inclusive lines on my inequality signs. Right, I'll do one more example and try not to make a mistake. As always, though, there'll be a help session so you can get in touch if you need anything. But I will try and get through one without making a mistake. Let's see. let's try and do modulus of 2x minus 3 is less than x. Let's do this and see what happens. So, first thing I need to do, I need to draw my graph of 2x minus 3 so that I can draw my graph of modulus of 2x minus 3. So somewhere, draw me a 2x minus 3 graph. 2x minus 3. Something like that. It crosses at minus 3, and every time I go across 1, I go up 2. So it looks something like that. And then what do I want? I want, when is this? I want the modulus of this. So I'm going to be, instead of going down, that part of the graph is going to go up like that. Okay? So that's what my modulus graph looks like. I might just keep working on this one. So you could do it in pencil, and then you could make this part dotted to make it clear that that isn't involved in your picture. So, so that's my modulus graph there. And now I need to draw the other graph, which is the graph of y equals x. So hopefully you're happy that the line y equals x is a diagonal line a bit like that. And we want to solve, when is the graph of modulus of 2x minus 3 less than the graph of y equals x? So from the picture, you can see that we're interested in this bit here. We're interested in this bit kind of under the line y equals x. So we need to find these 2 points of intersection. Yeah, we need to find this one here, and we need to find this one here. So now we need to think which one comes from the graph that hasn't been altered and which one comes from the altered graph. The reason I'm really emphasising this is sometimes it will be this part that isn't altered. Imagine if you had a negative gradient and your line was going down like this, it would be this part that wasn't altered, and then this part is the altered part. So that's why I'm really, really stressing that you need to think about every question really, really carefully. So, well, let's do this one first. So this part of the line was down here. So this has been affected. So this part comes from taking the negative of all of those values. That's going to be a minus, a minus. It was a minus 1, now it's a 1. So I put a minus outside the bracket, and I want that to equal x. That's going to give me this crossing point here. So minus 2x plus 3 equals x. So I've got 3 equals 3x. So I've got 1 equals x. So x equals 1. That's this crossing point here. Now, don't just do it from your graphs, because chances are in the exam the answer will be something like 17 over 11 or something. So don't ever do it from your graph unless it tells you to do so. Because often it might look like it crosses in an exact point, but actually it's like 21 over 22 or something like that. So make sure you, make sure you are doing it algebraically. And then I've got this crossing point here. Well, this part of the line hasn't been altered, and it's crossing this line. So I'm going to have 2x minus 3 equals x. So I'm going to have 2x equals x plus 3, and take away an x. So x equals 3. So they're my 2 points of intersection, but that's not what I've been asked for. I've been asked for when is this graph less than that graph. So when is my modulus graph less than the line y equals x? Well, it's between these values, and again, I don't have an inclusive inequality, so it's just going to be between the values of 1 and 3. Now, sometimes you could be asked to do this with 2 modulus graphs, but again, you're just going to draw the picture. If you draw the picture, all the decisions are taken out of your hands because you can just look at the picture. Okay? There are loads of examples in the book of how to do this. Okay? So if that doesn't make sense, if my waffles haven't helped, please have a look at the book. If that still doesn't help, let me know. There will, as always, be a help session this week, so come along to that if you need to. I'd like you now, please, to have a go at exercise 2A. If you're wanting to move ahead, that's absolutely fine. Just make sure you're letting me know where you're up to. You could start reading the next little bit on functions if you've got spare time. Functions can be a bit confusing, so if you've got a little bit of time and want to read ahead, you are more than welcome to, and just see how far you get. Don't necessarily do any questions, but just have a read so that when I do talk to you about it next week, it's not a massive surprise. So anyway, your job for this week is 2A. Please, please, please draw the picture. And I'll talk to you all soon. Bye.